G'day, I'm Dave Hughes from Zero Bubble Model Design. I thought I'd make this video today to talk about the way I set up my submarines. Simply because I have quite a few people who inquire about how I set up my watertight cylinder. They're interested in the kit and they don't quite know how to set up a cylinder, particularly if they're just starting out with model submarines. Even though my models are pitched towards people who've had experience with model submarines and who know how they want to set up, so they buy my basic hull kit and they're expected to know how to put a cylinder in or how to do a ballast system and to use one of the several ballast systems that are available on the market, or if they wish to develop their own system or design, they can do that. But I've had, as I said, interest in people saying, what ballast system would you set up, what cylinder design, or I want to start off with submarines but I don't quite know where. I can build a model, I can build a kit, but the actual electronics and setting up a watertight cylinder is a little bit beyond what I'm able to do at the moment. So what I'm doing is I'm going to take you through my ballast tank design, my cylinder design, what I found works, what I've avoided, the pitfalls, the successes that I've had, and hopefully will impart a bit of wisdom, or at least a part of experience that you'll be able to look at and go, that sounds great, or that's a good thing, or maybe I've found that that's a problem too, and yeah, it's good to avoid, and this is a possible solution to that. So I'm going to show you various elements of how I set up my designs, which is pretty consistent across all my kits. And I will go from there. So I hope you enjoy this, but more to the point, I hope you find that this is a good video that helps you put two and two together and go, okay, I can do this, because for a lot of people building an RC submarine is quite a daunting experience if they haven't done it before. One of the things that I do tell people, if you are interested in developing a model submarine, you've never built one before, is you've got to love problem solving. If you don't like mechanical problem solving, it's best to walk away from this hobby. It is technically demanding, it's challenging, but that's the fun of it really. If you love doing that, then welcome aboard. If you're not good at fixing mechanical things, it's probably not the best thing for you. But despite that, I hope this video helps you. Simple as that. Thank you for your time. So here is my basic watertight cylinder design, and as you can see, it's one central system with no divisions. There's no ballast tank in this setup. The ballast tank is actually at the front, in front of this unit. As you can see, the front of the unit is here, where you've got the windscreen washer pump. That's just a 12-volt windscreen washer pump that you'd use in your average car, and it's bolted on the front. I basically created a 3D printed bracket that's barely holding on at the moment. I need to replace it actually. It's bolted on at the front, and what it has is at the top you've got the electrical connections are basically been covered over with a water resistant film, basically like it's not a silicone, it's liquid electrical tape, and it basically goes down to a series of watertight connections underneath right here. You can just see them at the back there. Then what happens here is this electrical connection that you see here is basically just using an XT60 plug. This is your main power supply that runs your servos, it runs your motor, and also runs the pump. So what happens is all your electrical connections go in there. I use a simple 12-volt sealed lead acid battery to power all my systems, which is a fantastic thing to use. It's simple technology, it's very reliable, and it's reasonably cheap, and it can go in water. Okay, so that's the battery that I use. I just let that charge up. It has a connection, obviously, that fits this, and you can charge that off a car battery charger, which is fantastic. So here I've got my electrical connection in. You can see the pump connection goes through the bottom in here, and the windscreen washer pump, the inlet is here, and you can see a nitro tube here goes inside the unit. Now what I've done is, as I've said, I've shown you the unit with the cylinder on. I never store the watertight cylinder with the actual cylinder tube on. I dismantle it And this design is really good for that because you can dismantle it really easily. I can dismantle, pull the end caps off, slide the hot unit out in about 5 minutes. And any person who runs a model submarine will tell you that you need to make sure that when you've run your boat, you ventilate it well. There's nothing worse than moisture staying trapped inside a cylinder for a day or two, particularly if it's a warm day in summer. And the moisture and the humidity will affect your electronics, and you'll come back and run the boat 2 days later and something will not work because there's moisture. I always take my cylinder apart just as habit because I want my stuff to last. The other reason why I do that, and I'm not advocating this, but you can certainly use it, and I've used them very successfully, is that my actual cylinder is acrylic tube. Now, there are a lot of people probably shaking their heads right now saying acrylic tube, they'll never touch it, and I understand why. Acrylic tube is really quite brittle stuff, and it will crack really easily, particularly if you get differing expansion and contraction between different materials, particularly the end caps and the acrylic. If they expand or contract with hot weather, humidity, heat stuff, you'll get cracks. And certainly if you leave it tightened up overnight, temperature change, you'll wake up the next morning and there's a dirty great crack along the top of the cylinder, and that is not good. So I wouldn't suggest using acrylic. However, I've been using it for 10 years, and because I have the boat tightened up, bolted up, ready to go, and I'll only have it tightened up like that when I'm running it. As soon as I pull it out of the water, I'll pull the thing apart. It's actually only tightened up and bolted up and sealed up for a comparatively short period of time. The better material to use is definitely polycarbonate, also known as Lexan. It's about 3 times the price. It's much more expensive, but it's so much tougher. It will handle a lot more. Acrylic, as I said, is brittle. It can break very easily, particularly if you're drilling holes really close to the edge of the acrylic. That can cause problems. However, in saying that, I've used it for 10 years. This cylinder is 3 or 4 years old. It's quite good. And I've really had very few problems. I have had a few cracks that I've used with super glue on them. As I said, polycarbonate is a better suggestion. However, my end caps are also acrylic. I've machined them up on the lathe and they've been fine. And also the motor mounts here, the twin motor mounts, are also acrylic. So acrylic is good, but you do have issues with brittleness and cracking. So just putting that out there for you. Next, what I'm going to do is take the cylinder off. Oh, by the way, what I do is I have basically, I like to secure my cylinder with threaded rods that go through, and I've got a top and a bottom threaded rod here because the motor mounts, usually I would traditionally have them on the side, but I have them top and bottom simply because the 2 motor mounts are taking up the side positions where I would traditionally have the threaded rod that runs through. The threaded rod means that you can then put a little O-ring, a washer, and a wing nut on both of these. I don't have them at this end. I don't need to. They're bolted in there, so I only have them at one end, and I can tighten them up, and then I can really be sure that those end caps will not blow off with changes in pressure and so forth. And then I can blow pressure into the boat, pressurize it, put underwater, and test for bubbles. But I'm just going to take the cylinder off now and show you how I've set up my internals, because that's really what you want to know about. Okay, so here is the cylinder pulled apart without the cylinder, without the acrylic cylinder. You have the back end, you have the front end. Basically, the boat is divided into 2 separate sections with 2 separate trays. Trays being the flat surfaces where everything is basically mounted to. The front tray is quite short, and it only basically goes from here to here. And all it really has is the setup for the pump. Now, I use what's known as the shearline system, which is a UK system where you basically just got a pinch valve. This is one of the earliest ballast systems. I think it's been around for a long time, probably decades. And it basically uses, it's pretty crude, it's pretty simple, and it basically just uses a servo with a roller bearing that pinches the silicon line. Now, at the back here, we have the silicon line coming from the pump. So here we have the pump line coming through here, and we have the silicon pump coming through here. It comes through a bracket, and basically it goes back out here. Now, on the next video, you'll see that this outlet point attaches to what you can just see in the corner of the screen here, which is the pipe that runs to the ballast tank. So what happens is the pump circulates water inside the watertight cylinder and then back out again to the ballast tank. And all it is a servo with a roller, and it pinches. Basically, it rolls either way. When it rolls this way, it releases the pinch and it hits a micro switch. That micro switch turns the pump on. So the boat dives. The boat's dived. You release the switch, you bring back the roller wheel to the pinch, and it pinches the line. So the line is pinched, no water can get back. To surface the boat, obviously the roller moves this way and the pressure is released. The air forces the water back out through the system. So it works kind of like a super soaker. Basically, you're increasing the air pressure in the tank and that forces the water back out. It's a really simple system. It's very reliable. It's just not quick. It relies on a pressurized pressurized ballast tank, but I like it because you expend the energy to dive, you release the energy to surface, rather than releasing the energy to dive, and rather than having to have energy to surface as in an aspirated system or so forth. You've already got your air reservoir and you can blow it and come back. So I kind of like that, even though there are negatives about having a pressurized system. I've always liked it. It's just me. So I've got that there. Now in the middle of the tank, you'll notice that there are a series of these little brass pins. These brass pins are the 3 brass connections for this servo. And here are your positive and negative power supply for everything else, because at this point, the whole system detaches like so. And you can see that when I'm putting the boat together, these pins have to come together and basically register. So the pins auto align as I push it in, engage, and 5 pins have to engage for everything to work, for the power to go through and for this servo to pick up. Those pins were quite fiddly to make, but I'll tell you what, it makes this boat incredibly easy to put together and pull apart. As I said, I can pull the cylinder apart in a couple of minutes and have it ready in no time. It's fantastic. I like this, the pin alignment setup. So what happens is here, if I put these together and if I push these push rods through like so, you can see the pins should lock into place like so. That's how I use that system. The rest of the boat is pretty straightforward, the back end. So the back end, basically, it looks like a bit of a spaghetti mess, and I basically had to call in the riot squad with a rubber band here because all the wires are all over the place. But I basically have a speed controller here, which is an M-Tronics 15 speed controller. I also have a Corona synthesized crystalless 36 megahertz receiver, which is beautiful. They're lovely little receivers. 36 megahertz is what we operate in Australia. I know over in America it's 72 and 40 and so forth. Here in Australia it's 36 and 40 megs. I also have a little battery checker which tells me with a series of flashing lights the status of my sealed lead acid battery. I also have a fail-safe underneath. The fail-safe basically means that when the servo doesn't receive a signal, it blows the ballast tank. So it twitches the ballast tank servo off. And what's good about that is I usually have it turned off. So I usually have it off to the side. What that does is it means that there's not constant strain, side strain on the servo bearing, but it also means you don't get any pinch memory in the silicon, which is good. As I said, it's a bit of a crowded setup here, but I've got 2 servos here that go to the back push rods. Here you have one of the back push rods to the rudder and to the hydroplane going through my lovely little Nilex valves here. My receiver line is through here and it goes through this line to an external antenna outside. If you don't already know this, 2.4 gigahertz is somewhat temperamental underwater. There are people working on developing 2.4 gigahertz systems that will work underwater, but inherently it doesn't. That's why I've been buying up 36 megahertz gear like it's nobody's business. I've got a box full of 36 megahertz receivers, and I treat my 36 megahertz transmitters like they're gold, because they're being phased out, they're no longer being manufactured, and if there's a glitch with one of them, I have yet to find someone who can fix them. So I hold on to them very, very jealously. The two motors are mounted here, okay, and they're direct drive through, straight through, with a cup seal or a tiny little seal inside, machined acrylic parts with your little couplings there. So that is basically my ballast tank setup. I hope that helps. It looks daunting with the amount of wiring and cabling, and that confuses people. Also, I didn't mention there's a voltage regulator there. The voltage regulator takes from 12 volts down to 6 volts so that you can run the systems. Now I run 12 volts to the pump, and I run 6 volts to everything else. I don't think I run 12 volts to the motors, but I'd have to look at the circuit diagram. And certainly I can provide the circuit diagram that will show you all this complex maze of electronics. I can certainly have that there, and once you see it all makes sense. But the RC system works off 6 volts, the pump runs off 12 volts. So there you have my basic cylinder design. I hope that makes sense. The challenge is obviously keeping everything as watertight as possible. You want to try and have as few hull penetrations as you can. One of the things that I would suggest, if you are serious about working with model submarines and building RC systems like this, get a drill press and get a metal lathe. They are two indispensable things. Yes, I built watertight cylinders without a lathe, but a lathe means that you can machine up these end caps, and as you can see, O-rings and a bit of lanolin are just awesome for sealing subs. There's a little bit of an art to making this bulkhead, and I think for a lot of people, building the tray, putting the electronics down isn't the daunting thing. I think for most people who are starting off building a cylinder, it's all this here and all this here. It's keeping the water out that's the challenge, not building the setup inside, which is relatively straightforward. I am not brilliant with electronics, but I know enough to make a simple circuit and to plug things together. What I have had to develop and learn is the art of waterproofing. It's not impossible. I've got watertight cylinders that I've had for 10 years that still run. So you can do this. Believe me, you can. But you've got to love the journey. You've got to love the stimulus of problem solving, because it will keep you on your toes. But when you get this thing in the water and it's running beautifully and it comes back and there's no water inside the cylinder, it's just a great feeling. So I really hope that helps. Next we'll look at the ballast tank system, and that will wrap up this video for now. So I hope you found this helpful. So here we have the ballast tank design. Here is the nitro tube that goes to the front nozzle that you can see here. The front nozzle here basically takes the tube from the front of the ballast tank and it attaches to here. Goes through your offtake barb, and there's a pickup which is basically a plastic tube that runs along here and runs down to the very bottom inside the tank. There's a baffle inside the tank that's made out of PVC pipe like this, and it basically acts as a slosh deterrent for the water inside. But talking about the actual ballast tank, it is a 70mm wide PVC pipe. Okay, so quite thick PVC pipe with these two really thick PVC end caps, which you can buy at Bunnings, or if you're in the States, Home Depot, I presume. Bunnings is our big supplier over here. And it's basically just a PVC pipe with these two really thick end caps, so you can just buy it and you put them together. Because it's a pressurized system, I use the Green Plumbers pressure goo, which is this glue that sticks PVC. It's designed to be under pressure, and I'll tell you what, it sticks PVC like it's no one's business. It's very, very effective, and it will seal this tank beautifully, because the tank needs to be sealed. It's going to be, the water is going to be forced in, and it will, when it's fully ballasted and filled and the boat is submerged, you'll have about 60% water, 40% air. So that air in there, that 40% is pressurized. You don't want even a small pinprick hole, otherwise you'll get a stream of air coming out. So this has to be pressurized. And the beautiful thing about it being isolated is if there is a pressure problem, and if it was actually an integral part of the cylinder, you'd have leaks in the cylinder. So being isolated is just an added safety feature, particularly for your electronics. I've made an L bracket here, you can just see the end of it, and you can just see it here. It's held on with glue. And all I need to do to take this cylinder out is undo 2 nuts, stainless steel, 306 grade marine stainless steel nuts here, and I can unscrew the whole unit and I can put it in and put it out. It took me probably half an hour to make that ballast tank. It's pretty straightforward. It's really simple. The hook at the top here is simply for this to connect through so that I don't have cables running down the side. Nothing worse than when you put the top on and there's a cable hanging up sort of along the equator. It's frustrating. The red little things here, they're simply for your antenna that runs the whole length, and I place them through here, and there's one here in the foam. The battery sits right here beyond the scope of what you can see. But the ballast tank is a beautifully simple design. It's extremely effective because it's pressurized. The boat, you expend the energy and you use the energy to dive the boat, then you simply release the energy to surface the boat. And that's, I suppose, what I really like about this system. It's very reliable. As I said earlier, it's based on the Shearline UK system, pressurized water tank. It works like a super soaker, just with an electric motor, which is, of course, the 12-volt pump that we have here that powers the system. This here, I don't have a Schrader valve. When the boat is fully ready to go, I basically take this little brass pin out and I blow air into it, pinch it, push that back in, acts as a stopper, and it's my way of pressurizing the cylinder. And then I can put the cylinder underwater and look for air bubbles, and it tells me where there are leaks. So it's a really, really dead simple system that you can use. One of the things that you'll find with radio control model submarines is that if you've got a system that is really simple but really reliable, use it. Don't try, if you can avoid complicating things that can be kept simple and reliable, do it. Don't be scared to use a system that everyone uses because it works. The systems that get used are the ones that work. The systems that don't work very well tend to get discarded and aren't popular. There's a lot of systems that will require you not to reinvent the wheel. You just go into a hardware store and you find a part and you think about its use differently and how it can be applied to submarines. And that's pretty much what I've done. I've just taken hardware and used it for a different purpose. But you don't really need to reinvent the wheel with model submarines. The systems that work well, as I've said with this one here, it's brutally crude, but it works really well. So the connection to the ballast tank pipe that you see here, this little black plastic part here where my nitro tube attaches onto the ballast tank and where there's a plastic pickup that goes to the bottom of the tank. This little thing here is called a barbed offtake. It's a 4mm barbed offtake, and I pick it up at a hardware store, a place called Bunnings. This is the brand Pope. Now it's probably an Australian brand, but there you have the 4mm barbed offtakes. And what they're used for is they're a micro irrigation system that are used for, micro gardening stuff. And this is what they look like. So that's one there, okay? It's barbed at either end, as you can see. Now, what I do is I get a knife and I cut that smooth so it will fit through one end, glue it down, and put the nitro tube over the other. Now, what's really good about this little system is that it can also double up and be used as your push rod sealing for the end of your watertight cylinder. These little guys are fantastic. So I'm just going to move the camera over so you can see what I'm talking about. Now, if you have a look here, you'll see that I have two of these barbs here. Now, this one, I should actually have the tube slide over like that, but basically there's a little bit of nitro tube over the top. Often I have an O-ring there, and what happens is these little push rod seals, I think they must be an Australian thing. I haven't seen them on US or UK models or anyone else other than guys here in Australia. But basically, if I take a piece of 3 32 brass rod, like so, these 4mm offtakes fit perfectly. They are just a beautiful fit, like so. They're just gorgeous, like that. What I do is, once again, I cut off the barb at one end, push it through that way, glue it in, and then what I'll do is I'll put a bit of silicone tube over the end there, press it over the barb, and have the silicone tube just touching just at the mouth of the barb. So it requires a little bit of force, like so. You can put a tiny O-ring over that if you wish to, and you'll find that even though it's a thicker 4mm brass rod, I know that Dave Merriman and so forth uses much thinner. I've found these to be very low friction, and combined with a bit of lanolin or a lubricant there, these things don't leak. They don't need to be replaced. When I first started building RC subs, I played around with bellows. I bought a set of bellows. I found them rather expensive, and all it took was a pinhole to get a leak in them. And then I saw this system, and I've never looked back. I've never needed to replace one of these. They cost about 20 cents to make. The barbs, I've got packets of them. I think it's $3 for a pack of 20 or 30 of them. So it's just, they last forever. This system is extremely reliable. As I said, I don't trust bellows. I prefer this system. Now, you might like bellows, but I'm telling you now, this is a really good, extremely reliable way to seal your push rods, the back of the boat, and also for use with your ballast tank system. So here you have the stern linkages. What I have here is, I'll just get my antenna out of the way. The yellow cable there is my antenna, and it basically goes forward right up to where the battery is, but we'll have a look at that a little bit later. What you see here are the two drive shafts. This is a twin drive unit, and it's sitting currently in my Project 667 Delta IV ballistic missile sub. I've recently changed over to these magnetic couplings. I've seen Dave Merriman play with them enough times, and Bob Martin and everyone else, thinking they look really good. Bought some little magnets, powerful little magnets, made my own little brass housing, soldered them onto the push rods. Found that sometimes with the pull, they might come loose, even though I've obviously tried to make my hydroplanes move as freely as possible. Sometimes I've found when they pull, they don't quite, the magnetic pull isn't enough, particularly if they're a little bit stiff. So what I've actually done is I've actually put a little bit of nitro tube over the top of the magnet, just as an extra incentive for it to grip a little bit better, and I've found that they work really, really well. These little magnets are fantastic. Previously I had a little clamp system which was a bit fiddly. You had to make sure that your drive couplings slotted into the red little coupling, but you also had to then slide through and get a screwdriver and clamp them together, which was a bit fiddly. Now all I have to do is really just unpull the couplings, and these will uncouple, and they'll automatically attract when they're in proximity to each other when you're setting it all up. They make it quicker, they work very reliably. These screws sometimes had a habit of slipping, but also importantly, the screws didn't allow the radial flex of the horn to allow the brass rod to move with that. These magnetic couplings will give you a slight radial flex, which means that your coupling can move as it moves through the radius of the horn, which is really good. Here you've got your rear drive mounts, making sure that they move freely. The secret to a good back end here is to have everything move as freely as possible. Have particularly the drive shafts, no binding, no pressure, no stress, no unevenness. Everything running smoothly makes your life a lot easier. You also should put a fair bit of ballast down the back. I've had to pack a fair bit of ballast in the back of the boat to get that to work.